You believe you have a solid grasp on time. You strap a watch to your wrist. You notice the years piling up on your body. You can recall what happened yesterday and make plans for what comes next. Time feels completely straightforward, the most instinctive part of existence. But that feeling isn't time itself. It's only an impression, a clever deception your mind runs on you. Most people carry around this lyrical picture in their thoughts, time as a river. You picture it streaming forward, carrying you from what was, through what is, and on toward what will be. You sense it in motion. But that elegant picture has a serious flaw. If time really is a river, what is its actual speed? 1 second per second. That answer is empty. It's the same as declaring a table measuring 1 table in length. It explains nothing meaningful about how reality functions. The actual situation is far stranger, far more mechanical, and frankly much less poetic than a gentle current. Time does not stream. Time does not carry you along. And if you assume you truly understand it simply because you can tally seconds silently in your mind, get ready for a sharp shock. Begin with what happens inside your skull, because that's where the misunderstanding starts. You assume your inner sense of time is accurate and dependable. It isn't. It's a jumbled collection of personal shortcuts. Try a quick test, sit quietly and count steadily to 60 in your head, 1, 2, 3, and so on. You imagine you're faithfully following real duration, but in truth you're executing a highly individualized routine. For some, counting means hearing an inner voice quietly saying the numbers. You're essentially talking to yourself under your breath. If someone suddenly asks you a question that requires speaking aloud, the count breaks, the process stalls. But others experience something completely different, they don't hear any voice. Instead they visualize a kind of mental strip with numerals advancing like frames on a film reel or numbers scrolling across a display. Click, click, click. People who count this way can actually keep perfect track while reading a page, sorting laundry, or studying fabric designs. They can multitask without dropping a beat. But the person who relies on the inner voice can't glance at a single sentence without losing their place. This difference reveals something essential. What you perceive as the steady advance of time is nothing more than a constructed pattern your brain invents. It differs dramatically between individuals. It is not a fixed, universal feature. It is a neurological fabrication. So when physics enters the discussion, when we examine the actual structure of the cosmos, we must set aside personal feelings and focus on measurable operations. We don't chase vague notions of what time really is, in some metaphysical sense. That's a debate for late-night conversations over tea. Instead we ask, how do we define and quantify it in practice? The answer is straightforward and almost anticlimactic. Time is simply a method for sequencing occurrences. Nothing more. Picture a row of playing cards spread across a surface. You can state that the jack appears before the queen and the king follows the queen. The cards themselves are motionless. The surface isn't sliding. The sequence is merely an arrangement, a structural fact of their placement. Time is that surface. Events are the cards. When we say time passes, we are simply reading the arrangement from one end to the other. This leads directly to the most widespread error. You imagine time as a kind of container or stage. You envision the cosmos as a vast empty room, and time as a clock mounted on the wall, steadily ticking regardless of what happens inside. Even if you stripped away every star, planet, atom, and photon, you suppose the clock would continue its rhythm. Tick, tick, tick. That picture is wrong. It is the old Newtonian conception, and it has been overturned. Time is not an independent backdrop. Time is nothing more than a way of quantifying change. If nothing whatsoever in the entire cosmos alters, if no particle vibrates, no photon travels, no energy transforms, then time loses all significance. It becomes impossible to define an interval without some physical process to serve as the marker, a pendulum swinging, a quartz crystal oscillating, a cesium atom cycling between energy states. Time is inseparable from the physical contents of reality. It is an attribute of matter and energy, not a separate entity. Your intuition immediately objects, but surely time influences things. Time ages me. Time turns milk sour. No, it does not. That is a trap of language. Time possesses no agency. It has no hands to reach out and act. Bacteria spoil the milk through chemical reactions. Oxidation, microbial growth, entropy gradients, these are the actual agents. Time is merely the ledger we keep to record how quickly those processes unfold. Saying time caused it is equivalent to saying inches constructed the building. Inches never laid a brick. Carpenters did. Inches simply provide the scale by which we judge the placement of walls. Time is the measuring stick, not the builder. Now extend that analogy further, because this is where reality becomes genuinely bizarre. If time is only a measuring tool for spacing out events, what happens when the measuring tool itself bends and warps? This is not speculation, it is experimentally confirmed. We once assumed a second would be identical everywhere, no matter the location or motion. A clock on Earth and a clock on another planet would advance in perfect synchrony. It feels intuitive. It feels correct. It is completely incorrect. The pace at which a clock advances depends on its velocity and its position in a gravitational field. This is not a flaw in the mechanism, it is a core property of space-time. Imagine you are steering a vehicle across an enormous flat plain. You can travel due north or due east. If you head straight north, you cover the maximum distance northward. But if you steer northeast, you divide your total speed between north and east directions. Your northward progress slows because part of your velocity now points elsewhere. Replace north with progress through time and east with the progress through space. This is the heart of special relativity. Every object moves through spacetime at a fixed total speed, the speed of light in vacuum, for anything with zero rest mass, or close to it for massive objects. That total velocity is constant. The only question is how it is distributed between the time direction and the spatial directions. When you sit motionless relative to your surroundings, you devote your entire motion to advancing through time. You race into the future at the maximum possible rate, 1 second per second from your perspective. The instant you begin moving, whether walking to the kitchen or launching into orbit, you redirect a portion of that motion into spatial travel. Mathematically, you must therefore advance more slowly through time. Your personal clock rate decreases. Your biological aging rate decreases. You haven't damaged anything, you have simply reallocated your fixed spacetime velocity. If you could reach the speed of light, which nothing with mass can, you would allocate 100% of your motion to space and 0 to time. From the perspective of a photon, emission and absorption occur simultaneously. The entire history of the universe collapses to a single frozen instant. You don't notice your wristwatch lagging when you sprint to catch a bus because the effect scales with velocity squared over c squared. At everyday speeds the deviation is microscopic. But it is real. Global positioning satellites orbit at high velocity and sit in weaker gravity than ground stations. Their onboard clocks run faster than ours by a predictable amount. Engineers must apply daily corrections using relativity equations. Without those adjustments, GPS positions would drift by kilometers within hours. Another illusion arises from the way we register sequence and direction. We experience time as having an irreversible arrow, the past is set, the future is undetermined. You can vividly recall this morning's meal but not tonight's. Why? Most fundamental laws of physics are time-symmetric, equations run equally well forward or backward. A planet in orbit looks natural whether the film plays forward or reverse. Yet drop an egg and film the shatter, reverse it, and the yolk leaps upward, fragments reassemble, the shell seals itself. Everyone instantly recognizes the reversal as impossible. The asymmetry is not built into time itself. It comes from probability and statistics. There are vastly more ways for an egg to be broken and scattered than for those fragments to spontaneously reorganize into a perfect egg. Ordered states, few microstates, are rare, disordered states, many microstates, are common. As systems interact, they naturally drift toward configurations with higher multiplicity. That drift is what we call the second law of thermodynamics: entropy increases. The arrow of time is therefore thermodynamic in origin. It is the direction in which disorder grows. Your brain is exquisitely sensitive to that gradient. You register past as lower entropy states you can reconstruct from memory traces and future as higher entropy states still unfolding. In a hypothetical universe at maximum entropy, complete thermal equilibrium, everything uniformly mixed, no gradients left, there would be no usable change, no memory formation. No way to distinguish earlier from later. The arrow would vanish. Go back to those different counting styles, verbal loop versus visual ticker. Both are attempts to force a rigid, linear framework onto a reality that is far more malleable. We evolved those mental counters to predict tiger movements, track seasons, and coordinate hunts. Survival demanded rough estimates of duration, not precise insight into the geometry of space-time. Our minds prioritize utility over accuracy. We live in the immediate because that's where decisions happen. But in physics, the notion of a shared, universal present is fragile. If you and I stand side by side, our slices of now largely coincide. Move one of us at relativistic speed or place one deep in a gravitational well, and the slicing planes diverge. Events you judge simultaneously may lie in my causal past or future. Simultaneity becomes observer-dependent. The cosmos is not layered in a single universal moment, it is a static four-dimensional manifold of events. Different velocities produce different ways of carving that manifold into past, present, and future. This feels violently counterintuitive because you are translating a high-dimensional geometric truth into the narrow vocabulary of biological experience. You try to force spacetime to conform to the mental stopwatch or inner voice you use to sort daily tasks. When you do that, paradoxes appear. When you instead treat time as one coordinate among four, with metric properties that depend on velocity and mass energy, the mathematics aligns perfectly with experiment. We still have not addressed the ultimate boundary. If time is nothing but a sequencing of changes within the universe, what happens when we trace those changes backward to the earliest moments? Cosmological models show the observable universe expanding from an extremely hot, dense state roughly 13.8 billion years ago. Rewind far enough and densities rise, temperatures soar, and our current laws of physics cease to apply in recognizable form. All clocks, all atoms, all light paths exist within that evolving cosmos. So asking what occurred before the hot Big Bang is like asking what lies north of the geographic North Pole. The grammar allows the sentence, but the geometry forbids it. There is no before outside the manifold itself. The coordinate system we call time may simply begin there. Yet the inner counter persists. The mental voice or visual strip insists on a continuous thread stretching infinitely backward. Accepting a genuine beginning feels psychologically intolerable. We crave an eternal backstory. That tension between evolved intuition and cosmological evidence is unavoidable. We are finite organisms attempting to model an unbounded structure using wetware that evolved to track predators and fruit, not four-dimensional curvature. The beauty lies in the fact that even though our native sense of time is a crude approximation, even though relativity warps intervals and entropy supplies the arrow, the approximation is good enough for ordinary life. You can still hard-boil an egg, schedule a meeting, and watch a sunset. The deep structure remains hidden beneath layers of practical illusion. You do not need to master tensor calculus to cross the street. But understanding the machinery beneath is worth the effort. It reminds us that common sense is provisional, built on private mental shortcuts that vary from person to person. When two people discuss time, they may reach verbal agreement while their internal representations remain incompatible. One sees a scrolling tape, the other hears a counting loop. The same words trigger entirely different private simulations. That gap becomes critical when we move beyond everyday scales to relativity, quantum fields, or cosmology. Teaching these ideas is not merely transmitting facts. It is asking someone to rewrite their fundamental operating system, to discard the familiar ruler and quiet the familiar voice. Resistance is inevitable because biology fights to preserve its efficient shortcuts. Yet once the new framework clicks, the universe stops feeling hostile and starts feeling coherent. In the end, the strangest truth is this: your experience of flowing time is real as an experience, but it is not fundamental. It is an emergent pattern detection system tuned to increasing disorder in a universe that, at the deepest level, is a timeless block of events connected by causal structure. The river never flowed. The cards were always laid out. You simply learn to read them in one particular order.